Also on your choice boards today, it wants you to talk about different types of points and lines and angles. And just as a review, I thought I would go over that this morning as well, because it has been a while. You don't have our carpet in the back to go check when you're at home. So types of shapes. So we have, I'm going to put the, down here, I'll put the name on one side, and I'll put a drawing of it on the other image. So the first one we've got is a point, and that's just a point in space. It doesn't have to be this big. It could be a tiny speck, or it could be really big, but that is a point. It is the only one-dimensional, I'll put 1D for short, one-dimensional thing that we have is just a point. After we have a point, when we have 2 points connected with a line, then you start getting into two-dimensional objects. So a line segment would be 2 points connected. And notice that the line segment doesn't go anywhere. Remember, a line goes forever and ever and ever and ever, like never stopping. But a line segment stops at those 2 points. That's why we put those points there and the dots and not the arrows. A ray would come next. An array has a point on one side, and it goes and a line going out from it, and with an arrow on it. So this side is stopped. This side will never go anywhere, but this side is going to keep going. So think of a line segment as like a pencil or a pen, where it has a clearly defined front and a clearly defined end. It's obviously it only goes so far, but a ray is like a flashlight, where if I turn it on, obviously the light only comes out, doesn't come back towards me, it goes out and keeps going in one direction. An array is kind of like a sun ray or a beam of light, so that's how I remember that one, like a flashlight. And then we have a line, and a line has arrows on both ends. You could say there's points there, but we draw arrows. So a line goes forever and ever and ever. It's like this line just kept going and going and going, and up on the board over here, and it kept going down this way forever and ever, and it never stopped. And these three right here are all two-dimensional or 2D, because you have not just the point, but you've got it going in both directions. And then I also believe it wanted you to talk about perpendicular and parallel lines. And remember, I'll go over here, that when we write out the words parallel, it actually has parallel lines in it. 2 L's right here, and this third one actually over here, are in fact parallel to each other, because parallel lines go forever and ever and ever and ever and ever, and they never stop. They can just keep on going like railroad tracks, and they don't cross. I know you're saying, Ms. Canuttle, but railroad tracks sometimes do cross. Yes, you're right. However, 2 sets of tracks, one with one side of one wheel and one side of the other wheel, will not cross. Another set of tracks might come across and cross those ones, but that individual set of train tracks will not cross each other. That wouldn't work, right? The left wheel of the train can't cross the right wheel of the train. Like, the train would get all like wonky and twisted. So parallel lines never cross each other. And then perpendicular lines, perpendicular lines are lines that cross at exactly 90 degrees. So if we were to draw that, you would have your lines crossing with a 90-degree angle or a right angle. It would cross like that. So think like intersections in the street cross at 90 degrees, or maybe field rows, or window panes, or remember at the top of our ceiling, if you look up, it crosses at 90 degrees right there at the light, right there in the ceiling, right there. You can see that right there. Those are all crossing at 90 degrees. So I hope this helps you identify perpendicular and parallel lines. I believe it wants you in one of the boxes to draw two-dimensional shapes with perpendicular and parallel lines. So you guys know some of those already. Remember when we had our pictures on the board? You could draw, for instance, certain types of triangles have perpendicular and parallel lines. Remember, a right triangle, because it has that right angle, has perpendicular lines. This leg and this leg are perpendicular to each other. You also have other shapes like squares that have perpendicular and parallel lines. Remember, because squares have right angles on all of the corners. Those are all perpendicular. And these lines over here, this line and this line, are parallel because they're not touching. And they're never going to cross if I just keep drawing them. And this side and this side are parallel because if I just keep drawing them, they're never going to cross either. Remember, triangles cannot have parallel lines. There's only 3 lines on a triangle. Remember, tri, and that means that then they always have to cross at some point. But squares in triangles and other shapes with 4 sides have the potential to have perpendicular and parallel lines. I'll try to take a picture of some of our posters on the wall today and put it up with this video so that way you've got that as an example to look at as well.